In this video I will do number 41 from the homework in section 4.3. I just wanted to include this because there's some difficult algebra in the problem. Part A of this question asks us to find the open intervals on which our function increases and decreases. So what we're going to have to do for that, let's find our critical points. Then let's use our number line with our first derivative and determine whether it's positive or negative in those subintervals. So first let's differentiate. Let's find f prime of x. So differentiating e raised to the 2x, it'll be exactly that times the derivative of our exponent times the derivative of 2x. So it'll be 2e to the 2x. And then our second term, e to the negative x. If I want to differentiate this, same thing, it'll be e raised to the negative x, exactly what I see, then to take the derivative of negative x, which is negative 1. So we'll have minus e to the negative x. Find our critical points. We need to set this equal to 0. So I guess what should we do? Right now I'm thinking let's write it as one single fraction. We have trouble right there, that negative exponent. So let's rewrite this as 2e to the 2x minus getting rid of that negative exponent 1 over e raised to the x. And we are setting this equal to 0, solving for x. So let's get a common denominator. Let's multiply this first term, top and bottom, by e raised to the x. So our new exponent here will be 3x. So what do we see here? Let's solve our numerator for x. So I'll kind of break away from this and do that on the side. So 2e to the 3x minus 1 is 0. Adding 1 to both sides and dividing by 2 both sides. Then from here, want to get rid of that e. So we are going to have to take the natural log of both sides. So we'll take natural log of e raised to the 3x, which is equal to the natural log of 1/2. So do we get 3x, our natural log and e, they cancel out, so we get 3x is equal to natural log of 1/2. So x equals the natural log of 1/2 divided by 3. So that's what we get from our numerator. That'll be a critical point. And then let's focus on our derivative of the denominator here. Are there any x values that would make our denominator 0? And that answer is no. E raised to the x, that function, that expression, that'll never take on the value 0. Thinking of that graph, the graph of e raised to the x, that's always above our x-axis. It never crosses it. So we should get the one critical point. So from here, answering question A, so let's find the open intervals. So let's go to our number line. And this is with our derivative. So let's label that. Include that one value. So natural log of 1/2 over 3. Thinking about what this number is. This is a negative number. Natural log of 1/2. That is negative. How would we know that? Thinking about the graph of the natural log, every x value that's less than 1, it's all underneath our x-axis, so that numerator is negative. So I guess numbers I could pick 0. And then without thinking too much through this, what will this quantity be? So it's going to be negative. So I guess just to be safe, I'll probably go negative 10. Plugging these values into our derivative. So I guess I'll look over here. Plugging in 0. So f prime of 0 is equal to 2 times e to the 0 minus 1 over e to the 0. E to the 0 is 1. So for this we get 1. So that is positive. F prime of negative 10. I'm actually gonna stop and change this number. What I'm thinking, easy to evaluate whether or not it's positive or negative. I'm gonna let x be something in terms of ln, so that'd be easy to evaluate our derivative. So what should we do? Let's take ln of 1/2. That's something that's negative. Dividing it by 3, that'd push it to the right in value. So let's just take the natural log of 1/2. So ln of 1/2. Plugging that in, 2e3. So that first number I'm looking at here, the e and the natural log, it should cancel out. We have a problem right there. We have a 3 out in front, so we cannot have that. Thinking of properties of exponents, though, if we have exponents being multiplied right there, what we'll have, we can rewrite that as e raised to the ln 1/2, that whole thing being raised to the third power. So we can rewrite that to e raised to the ln 1/2, all being raised to 3, minus 1. Then we'll have to do the same for our denominator. E raised to the ln 1/2. Then once we get that, we'll cube it. So what do we have? Inside this parenthesis, it's 1/2. 1/2 cubed would be 1/8. So that's times 2 is 1/4 for our first term, minus 1 over 1/8. So we do get a negative number. So finishing up part A, let's just sum up what we have. I have a little bit more room here, so I'll sum it up. The question asks us find the open intervals where f is increasing or it's decreasing. So f is increasing. And this interval running from the natural log of 1/2 divided by 3 to infinity. And it's decreasing from negative infinity to natural log of 1/2 over 3. So that's part A completed. Part B asks us to identify the local and absolute extreme values of this function. So we only have one critical point, so that's the only place we're going to get an extrema. It changes from, the derivative changes from negative to positive, so we are going to get a minimum at this point. Let's find out what the y value is there to answer this question a little bit nicer. I'll slide my paper up. So let's find out what is f of natural log of 1/2 divided by 3. So plugging that in. Okay, some more work with our e's and natural logs. So first thing, we want to make sure that we just have the e's and the ln's touching, like we did over here when we found our derivative at the natural log of 1/2. So what we should do here, take let's get rid of that 2 and we'll square the whole thing. We also have to get rid of this dividing by 3. The way we will do that is by raising it to the 1/3 power. So how would that look? Well, if e raised to the ln of 1/2, and this whole thing we're saying will be raised to the 2/3 power. So let's do a similar thing for the next one. Plus e, gotta get rid of this negative 1 out in front, gotta get rid of the dividing by 3. So e ln 1/2, and this whole thing's being raised to the negative 1/3. So this first one simplifies to 1/2. And we'll have 1/2 being raised to the 2/3. And then we will have, again, 1/2, this time being raised to the negative 1/3. from here. So to get 1/2 raised to 2/3. What is that? If I first take care of my squaring, that would be 1/4. Then take the cube root of 1/4. So 1 over cube root of 4. And then 1/2 raised to the negative 1/3. So we'll flip this fraction. So we'll get 2 now in our numerator, that positive exponent. And then we'll take the cube root of 2. Simplifying this, I guess let's multiply this second term by cube root of 4, top and bottom. So what is this? 1 plus the cube root of 8. Cube root of 8 is 2. So we'll get that y value is 3 over the cube root of 4. And let's see what they ask us here. Identify the function's local and absolute extreme values. So we'll say that we have a local derivative changes from negative to positive. So that'd be a local min at x equals the natural log of 1/2 divided by 3. And that value is 3 over the cube root of 4. Thinking about the graph what we have, that's the only extreme what we have. Is this absolute though? What's the behavior of our function? So looking at our first derivative, for a while our function starting at negative infinity, it's going to be going downhill, decreasing for a while, and then at our critical point it'll change and then it'll start increasing. So we will have an absolute min right there. So absolute min. So this way is fine writing it. If you want to maybe write, say, absolute min of, if you're more comfortable writing that, of our y value at the x value, our critical point. And then since we don't have any local or absolute max, you don't need to say anything. Not writing anything is fine.